Hello students, in this session we are going to learn functions and inverse function. We'll be focusing more on inverse function as you already have learned functions and composition of functions. So this lesson will be focusing more on inverse function. Let's quickly start. So functions, so imagine functions are like a die and we put an egg into that and it converts the egg into a blue egg. So white eggs goes in to the function and becomes blue egg, which is a y. So function is bx, which is blue die. The white egg is the input, which is x, and blue egg is the output. Okay, so that's how the functions work. That you give input to the function in terms of x, it processes the input and it gives you the output, which is the y. So inverse function undoes what the function does. So inverse function of the blue dye is a bleach. So the bleach will undye the blue egg and make it white. So initially the egg was white and we put it in the function and the output was blue egg. Now in this case, the inverse function, you put it the blue egg in the bleach. Here the inverse function is the bleach and it gives you output as a white egg, which was initial white egg, right? So the bleach will undye the blue egg and make it white. So let's see the process. It undoes everything which was done by the function. So in the same way, the inverse of a function will undo what is the original function did. For example, let's take a look at the cube. Fx is equal to x cube. So if you put 5 into this function x cube, so this will give you 125 as the output. So now inverse function is like if you put the 125 in the inverse function, which is cube root of x, you'll get the 5 back. Like when you are putting the blue egg to the bleach, it was giving you the white egg, which was the initial x value. So here, if you substitute 125 to this in function cube root of x, which is inverse function of x cube, so you get the 5 back. Okay, so that's how the inverse function undo everything which was done by the function. Remember we talked about the functions taking a set x and mapping into a set y. So we have done this in the class. I explained you the mapping diagram. So here 1 is mapped with 6, 2 is mapped with 2, 3 is mapped with 4, 4 is mapped with 8, and 5 is mapped with 10. An inverse function would reverse that the process and map set y back into set x. So here we were giving 1 and you're getting the value 6. If you give 2, you were getting the value 2. That's what the mapping diagram means. So you give x to the function, you get y. So this is the mapping diagram, reverse mapping for inverse function. So inverse function would reverse that process and map from set y back into set x. Okay, so that's how inverse functions work. How do you determine that a function has an inverse? So how will we figure it out that the function is inverse? The function must be one-to-one function or a restricted many-to-one function. Okay, then only the inverse is defined. Let's discuss in detail. So one-to-one function. A function is one-to-one if each value in its domain is assigned a different value in the range. So for every unique x, you get unique y. Then the function is one-to-one. So only functions that are one-to-one have inverses. Inverse function is only defined for one-to-one functions. If we map what we get out of the function back, we won't always have a function going back. Let's see. See, here we are doing the mapping diagram and as you can see 3 and 5 for value of x 3 and 5, you are getting only a single y, which is 6. Now if you Now if you analyze this mapping diagram, here at two values of x you are getting the same value of y. This is many to one function, right? So in many to one function, now let's try to find out the inverse of this function, and let's understand what will happen if we try to find out the inverse. So let's understand the mapping diagram. So this is the reverse mapping, and now you can see here that when we are giving 6 to the inverse function, if you're trying to find out the inverse function, if you give 6, you're getting two values of y. That's violate the definition of function. For 1x you can't have two values of y, right? So in this case, for 6 you are getting two different values of the inverse function. So as it no longer a function, that's why inverse is not defined, because a function cannot give two values of y for single values of x, for a single value of x. Since going back 6, it goes back to both 3 and 5, the mapping going back is not a function. These functions are called many to one functions. So inverse is only defined for one to one functions. It means one value of x is one values of y. That's how you can map. And if you do reverse mapping, for one value of y, you get one value of x. Now in this case, all are mapped to 4. This is again many to one function. Inverse will not be defined, because when you substitute 4 back to the inverse function, you will have 5 different values. That violates the definition of functions. This function is one to one. Each x is paired with only one y, and each y is paired with only one x. So we can easily find out the inverse function. One-to-one functions will have inverse functions, meaning the mapping back to the original values is also functions. How to determine that a function is one-to-one? So we will try to understand using the mapping diagram whether the function is one-to-one or many-to-one. So this is a function f. 2 is mapped with 1, 3 is mapped with 7, 5 is mapped with 3, 9 is mapped with 0. These are the order pair 2, 1, 3, 7, 5, 3, 9, 0. If we map y to x back, so you'll get 1, 2, 7, 3, 3, 5, 0, 9. So here, as you can see, unique value of y's is giving you unique values of x, right? If you are mapping back y to x. So this means it is a one-to-one function. Now this is a function g, where minus 2 and 2 is mapped with 4, 5 is mapped with 25, 9 is mapped with 81. So in this case, as it is, as you can see, it is two values of x is giving one value of y. But when you mapped it back, if you map y to x, you will see that 4 is giving two different values of x, which is minus 2 and 2. So that is not a function then, right? One value of x cannot give you two values of y. So if you map it back y to x, that's not a function. That's why inverse is not defined. So this is g. G is not a one-to-one function, and inverse is not defined for this. Use a table of values. So from the table x and y value, you will see that whether the function is one-to-one or not. So for 1 it is you're getting 5, for 2 9, for 4 6, for 7 5. So for two different x you're getting same value of y. So it's not a one-to-one function, because one-to-one function, for a single x, for a unique x you get unique y. Here two different x is giving you same value of y, so it's not a one-to-one function, right? It's not a one-to-one. When we reverse the ordered pairs, the result is not a function, and if it is not a function, inverse is not defined. A function is one-to-one when different inputs always result in different outputs. So if C not equal to D, then FC not equal to FD. I explained you this concept in the class. So I hope you remember that if c not equal to d, it means 1 and 7 are not equal, then the function value should not be equal. Then it is 1 to 1. But in this case, 1 and 7 are not equal, but corresponding y value or corresponding function value is equal. That's why it's not a 1 to 1 function. Recall that to determine the graph, if an equation is a function, we have to do vertical line test. If you want to figure it out whether it is a function or not, we're not talking about 1 to 1 or many to 1 function. We're here talking about whether a curve is a function or not. Okay, so for that there is a vertical line test. So here, as you can see, if you draw a vertical line in the on the graph, you will find for each value of x you will get a unique value of y. So it is a function, right? This is a function. But ellipse, this is the ellipse. If you draw a vertical line, this is not a function because for one value of x you are getting two different values of y. This violates the definition of the function, so it's not a function then. Here, for one value of x you are getting one value of y, so it is a function. Okay, this is a function. That's how we find out whether the given curve is a function or not. We do vertical line test. Now there is another test, horizontal line test. That's for 1 to 1 or many to 1 function. We discussed it before, but let's revise it again. Horizontal line test. So if you draw a horizontal line parallel to x-axis, if the line is intersecting the curve only at one point, then it is 1 to 1. If it is intersecting more than one point, then it is many to 1 function. In this diagram, in this curve, if you draw a horizontal line parallel to x-axis, you will see that the line will intersect the curve at 2 points. That's why it's not 1 to 1 function, and that's why it is many to 1 function. Okay, it's not 1 to 1, hence it is many to 1 function, because for two different values of x you are getting the same value of y, which is 3. So in this case, fx is equal to x cubed. You draw a horizontal line, you will see that the line is intersecting the curve only at one point, so it is 1 to 1 function. How do you determine? Now here we will apply a horizontal line and we'll try to figure it out whether it is 1 to 1 or many to 1. Use the horizontal line test to determine whether the graphs are graphs of 1 to 1 functions. So as you can see here, if we have drawn a horizontal line, but it is intersecting at 3 points, so it's not 1 to 1. In part B, if you draw a horizontal line, you will see that the line is intersecting at only one point. So this is one, B is 1 to 1, A is many to 1 function, or not 1 to 1. This is, as we have already discussed, this is many to 1 function. This is summary for horizontal line test. So basically this test is used to figure it out whether the function is 1 to 1 or not. If any function passes the horizontal line test, it means the inverse is defined for that function. If the function fails the horizontal line test, then inverse is not defined for that function. How do you find the inverse function? So inverse function f to the power minus 1 is read as f inverse, and domain of the function is actually the range of f inverse, because x becomes y and y becomes x. So the domain of f becomes range of f inverse function, and the range of function becomes domain of inverse function. For functions, there is a vertical line test, and for the inverse function there is a horizontal line test. Okay, if the function passes the horizontal line test, then only the inverse is defined for that function. So how do we find out the inverse function? We first write y is equal to fx, then interchange x and y, and then make y as a subject, and then after making y as a subject we replace y with f inverse x. Any restriction on x and y should be considered. Okay. So let's do this question. So given that fx is equal to minus 2x minus 7, find the inverse. So we'll replace fx with y, where y is equal to minus 2x minus 7. Then first step, replace y with x and x with y. So this we have done, and then make y as a subject. So you'll get x plus 7 divided by minus 2, and f inverse x, replace y with inverse x, that x plus 7 divided by minus 2. That's the inverse function. Find the inverse of fx is equal to x to the power 5. So we write y is equal to x to the power 5, then replace y with x and x with y, and make y as a subject. And then you will get, finally, y is equal to fifth root of x. So f inverse x is fifth root of x. Does this y is equal to fifth root of x passes the vertical line test? Let's see whether this will be a function or not. So if we draw the diagram, if we sketch the function and then draw the vertical lines, yes, it passes the vertical line test. So that's why f inverse x is a function, and that's the correct answer. Fx is equal to 2x square minus 4. Determine whether f inverse x is a function, then find the inverse equation. So here is the fx, 2x square minus 4. This is the graph of sketch of fx is equal to 2x square minus 4. If we draw the horizontal line, it fails the horizontal line test, means inverse is not defined for this domain. So y is equal to 2x square minus 4, x is equal to replace y with x and x with y, and make y as a subject. As you can see that there will be two values, plus minus square root of x plus 4 over 2. That's why inverse is not defined. But later on I will explain it to you how we can restrict the domain and get the inverse function. So gx is equal to 2x cube. It passes the horizontal line test, it means inverse is defined. And y is equal to 2x cube, x is equal to 2y cube. We get y is equal to cube root of x over 2. Okay, so y is equal to, we can write it like that, cube root of 4x divided by 2. Find the inverse if it exists of fx is equal to 3x square plus 2. Now here we switched x to y and y to x, and we get y is equal to square root of x minus 2 over 3. But there is a problem here. Here you need to define the domain of the function, whether x is greater than or equal to 0 or x is less than or equal to 0. Find the inverse if it exists of fx is equal to 4x plus 6 over 5. So replace fx with y, and then interchange y with x and x with y, and then write y as a subject. That's the answer. How do we know that the graph of functions and their inverse? How do we know that the graph functions and their inverse? So, what is the, in other words, you can say what is the relation between function and the inverse function? Okay. So the function and the inverse function, they are reflection of each other around this line y is equal to x. Okay, along this line. So in other words, we can say they are symmetrical about the line y is equal to x. Any function and the inverse function, any function whose inverse is defined, it will be mirror images of each other around the line y is equal to x. Graphically, the x and y values of a pointer, so it means 4 7, so it gives you 7 4. If it is minus 5 3, so that will be 3 minus 5. Okay, and let's consider the function and compute some values and graph them. So we found out the x and y coordinates. Sketch the graph. Is this function 1 to 1? Yes, it is 1 to 1. And its inverse is defined, just 0.5x minus 0.5. We have plotted the function, that function as well, and as you can see, if you draw the line y is equal to x, they are mirror images of each other along the line y is equal to x. Okay, simple. Let's consider the function and compute some values and graph them. So fx is equal to x cube, you can graph them, and you can also figure it out that it passes the horizontal line test. That's why inverse is defined. So you can find out the inverse, which is cube root of x, and they are symmetrical about the line y is equal to x. F and f inverse x are inverse function, and f equals to b for real numbers a and b, then f inverse b has to be a. If you are putting in the function a and you're getting b, so in the inverse function, if you substitute b, you should get a back. If the point a and b is on the graph of f, then the point b a is on the graph of f inverse. And the domain of function is the range of inverse function, and the range of function is the domain of inverse function. And that I already explained you that the function and the inverse function are the mirror images of each other along the line y is equal to x. So this is a function y is equal to fx, and if you know the function, you can easily sketch the graph of inverse function, because the inverse function is symmetrical about the line y is equal to x. So here x is negative infinity, y is tending to 0. So for inverse function, for x is equal to 0, y should tends to negative infinity. So that's how the function and inverse functions work, and they are symmetrical about the line y is equal to x. So the domain of f is the range of f inverse, and the range of function is the domain of f inverse. So the domain becomes range, domain of the function becomes range of the inverse function, and the range of the function becomes the domain of the inverse function. Thus, we may be required to restrict the domain of f so that f inverse is the function. So now we will discuss how we can restrict the domain of many one function and convert it to one function. And once it gets converted to one, then the inverse is defined for that many one function if we restrict the domain. So here it is fx is equal to x square. But if we consider only the right part of the function, if we only considered x greater than 0, greater than equal to 0, then in this case it is a 1 to 1 function because it passes the horizontal line test, right? So for x greater than equal to 0, this becomes 1 to 1 function. Okay, here it should be x greater than equal to 0, and now it is 1 to 1 function. So you can make a function 1 to 1 by restricting its domain. Such a function will have its inverse. So now it will have its inverse, which is square root of x. If you do that, if you do the process, y is equal to x square, and then interchange x with y and y with x, you will get root x. So let fx is equal to square root of x plus 5. Find f inverse x. We need to find the inverse, so we'll do the same process. Fx with y is equal to square root of x plus 5, and then we will interchange x with y and y with x, and we get the answer f inverse x is x square minus 5. Now here, as square root of x plus 5, here the domain is x plus 5 has to be greater than equal to 0. It means x greater than equal to minus 5. That's the domain. It means this is the range of the function, right? Range of the inverse function. The domain is minus 5 to infinity. So that means the range will be minus 5 to infinity. So its inverse is this x square minus 5 for x greater than equal to 0. And as it is giving you as the range of the function was greater than equal to 0, y greater than equal to 0, that's why the inverse function has a domain of x greater than equal to 0. How do you prove that the function has an inverse of another function? So one function is the inverse of other function. How will prove? One method is we can check whether they are symmetrical about the line y is equal to x or not. If we don't want to use the graphical, that's a graphical method, but if we don't want to use the graphical method, then what is the proof? So this is the property that if g is the inverse function of f, if g is the inverse function of f, then FOGX, the composition, is equal to x. It means F inverse is equal to x, or F inverse OF is equal to x. For FOGX or FOF inverse x is equal to x, means for every x in the domain of G, or F inverse, or G of x is equal to x for every x in the domain of F. So this is the property FOG x is equal to x or g of f is equal to x, where g is the inverse function of f and f is the inverse function of g. They are inverse of each other. So these two are functions given. Let's check whether they are inverse of each other or not. So fx is minus 3x plus 6 and gx is minus 1 over 3x plus 2. So FOGX is equal to x. That's what we need to prove. So FGX, meaning find FGX or GFX. If they both equals x, then they are inverses. So FGX we are finding, it means we are substituting gx in fx. So if you simplify, you will get x. So that's true. Now we'll find GFX. So we are substituting fx in gx and we'll get is equal to x. So that's also true. So because FGX is equal to x and GFX is equal to x, they are inverse of each other. Composition of inverse function. So fx is equal to x cube and f inverse x is cube root of x. So f3 is 27. So that means f inverse 27 is 3. That's correct. And f of f inverse 27. So f of f inverse 27 will give you 27. F inverse of f3 is 3. So this is also another way to prove that they are inverse of each other. Verify the functions f and g are inverse of each other or not. So fx is x minus 2 whole square. For x greater than equal to 2, gx is square root of x plus 2. As you can see, this is many to one function, but the domain is restricted for x greater than equal to 2. So it is one to one function as the domain is restricted. So its inverse is defined. So let's find out FOG. And we are getting FOG is equal to x and GOF is also x. So since both of these equals to x, so they are inverse of each other. If f is 1 to 1, then f inverse exists. The domain of function is the range of f inverse and the range of function is the domain of f inverse. Right, this is the summary and they are symmetrical about the line y is equal to x. These three things are very, very important. So geometrically, if a function and its inverse are graphed, they are reflection about the line y is equal to x, and the x and y values have traded places. They interchange their places. The domain of the function is the range of inverse function. The range of the function is the domain of the inverse function. So also we start with the next and put it in the function and put the result in the inverse function. We were back where we started from. So that's what we discussed, and given two functions we can tell if they are inverse of each other if we plug one into the other and it undoes the function. Remember, subbing one function in the other was the composition of function. So if f and g are inverse functions, their composition would simply give x back. So f of g x equals to x, g of x is equal to x. Or you can write f inverse equals to x, or f inverse of f equals to x. Thanks for watching the video. Do watch the next video where I'll be solving past papers question. Thank you very much.